Hey guys, this is Mr. Sal. We're just going to look at some applications of those systems like we learned in 2.1. It's really just word problems with those systems of equations with two variables specifically. In the next section we'll be looking at three variable systems. So don't forget to like, comment, and subscribe. Just let me know what you think about the video below. Thank you. So this first problem kind of got me the first time that I did it, so here we are again doing this problem. But hopefully I won't make any mistakes. It's that statement right here where it says she has one less 6-cent stamp as 5-cent stamps. That can throw a lot of people off, but the good thing about it is if we check our work, we should be able to understand that we have made a mistake. So when I did it the first time, having written that equation wrong, it came out very poorly. We had some kind of decimal, which we know we can't have because we should have just a regular number of stamps. Okay, you can't have a decimal number of stamps. So with that in mind, let's go ahead and get started. Monique has a stamp collection of 5-cent stamps and 6-cent stamps. She has one less 6-cent stamps as 5-cent stamps. If the collection has a face value of 137 cents, how many of each does she have? So let's start with that equation that we'll write there from the sentence underlined in orange. So the first thing we should do is define our two variables. Now I'm not going to use 5 and 6 to represent those because we could get the numbers confused pretty quickly. So I'm going to say x is 5-cent stamps and y is 6-cent stamps. So this equation in orange here, I'm going to write it based on the 6-cent stamps, which is y. So she has one less 6-cent stamp as 5-cent stamps. So the 6-cent stamps is going to be the 5-cent stamps, but one less than that. And that's our first equation, actually, for our system. The second one would come from the collection having the face value of 137 cents. So we should be able to figure this out, the equation anyways, by taking the 5-cent stamps and multiplying it by 5, which will tell us the value that we have in 5-cent stamps. And if we take the 6-cent stamps and multiply that by 6 cents, then we should have the value from the 6-cent stamps. Then if we add these two together, we should get 137 cents. So this is set up pretty well. We can see the orange equation, y equals x minus 1, is set up so that we can use substitution. Now usually when we've done these in the past, we see both of them written in standard form. But since one of these has slope-intercept form, we're going to use substitution by replacing the y value with x minus 1. So that gives me this new equation. Next up, I'm going to distribute the 6 into the parentheses. Then I'm going to combine my like terms, specifically these two x's. 5x plus 6x is 11x's. And we can see this equation is getting a little bit smaller every time. Let's go ahead and add 6 to both sides of the equation to get the x's by themselves. And then finally, to solve for x, we're just going to divide both sides by 11. So we can see that x is 13. That means that we have 13 5-cent stamps. So I'll just write it like this. And that would be one of my answers. Even though I'm using x and y, I'm not going to write the answer as an ordered pair because this is a word problem, so we need to label our answers as I've done there at the top. Well, now that we have x, I'm going to go into the first equation, y equals x minus 1, and I'm going to replace x with 13 and then just solve for y. So there I go, I've replaced it. Next I'll just 13 minus 1, and then I've got y is 12. So the y was the 6-cent stamps, and I have 12 of those. Last thing I should do in this problem is just check to make sure that I have the right value or the face value of the cent. So I've got 13 times 5 and then 6 times 12, and this should equal 137, so I got a question mark above the equal sign there. So sure enough, I got 137, which equals 137. So it just checks off our answer, and we could know during a test that our answer is correct here. A man has 27 coins in his pocket, all of which are dimes and quarters. If the total value of his change is 555 cents, how many dimes and how many quarters does he have? Okay. So we have 27 coins. And again, it doesn't matter which one you choose. We got X and Y. So X, I'm going to say, is dimes. Those are 10-cent coins. And Y is my 25-cent coins. And my first equation is going to be based on coins. So the number of coins, I've got X number of 10-cent coins, and then Y number of 25-cent coins. If I add these, I should get 27 total coins. The next equation will be based off of the price, well, not price, but how much it's worth in cents. So for my 10-cent coins, those are worth, well, 10 cents each. So if I multiply that by the number of dimes, that will tell me how much it's worth. The quarters are 25 cents each. So if I multiply that by how many quarters I have, then I have the worth of my quarters. If I add these together, then I should get my 555 cents. All right, well, let's choose, because elimination is going to work here the best. Unless, I mean, you could use substitution as well. I'm going to use elimination, whatever. Which one do you guys want to eliminate first? So let's do substitution. If we do we want it to be y equals or x equals that top equation? All right, so that gives us an x value to replace into this x as 27 minus y. Let's distribute the 10 into the parentheses. And now we can combine our y's together. And now here we'll subtract 270 from both sides. And then finally, just to solve for y, we're going to divide both sides by 15. And that tells us y is, so that would be y 19 quarters. And now we need the number of dimes. And we see y is 19, right? So we can do 27 minus 19, which is 8. So 19 quarters, 8 dimes. And we could just make sure that it does equal 555 cents. So 80 cents from the dimes, and then 19 times 25, yeah. This adds up to 555, and it checks off, which we would want on an exam. A man flies a small airplane from Fargo to Bismarck, North Dakota, a distance of 180 miles. Because he is flying into a headwind, the trip takes him 2 hours. And on the way back, the wind is still blowing at the same speed, so the return trip takes only 1 hour and 12 minutes. What is his speed in still air, and how fast is the wind blowing? Well, I'm thinking miles per hour is going to be best for us on this. So we got 1 hour and 12 minutes. And I just want to change this into hours by itself, okay? So 1 hour and 12 minutes is the same as 1 hour and 12 sixtieths hours. So if I add these, I'm going to use a decimal on that, by the way.
Just change it to minutes.
Now when I add these, I get 1.2 hours. And that was for the return trip, which was with the wind, okay? So this one, I don't know. I'm going to use different variables just so hopefully it will come out a little bit more clear. And we're not dealing with cents here. So A will be the speed of the airplane. And I'm going to use W for the wind speed. All right. So just to start off, it says that he went 180 miles. And this was into the wind. Took him 2 hours. Okay. That means that you would have the speed of the plane. And you're going to subtract the speed of the wind. Okay. And that would equal the 180 miles in 2 hours, which really is just 90 miles per hour, right? Next, we need the return trip, which would take the speed of the plane, but we're adding the speed of the wind because it's going to make them go faster, right? So we should see some higher value than the 90 for the return trip. And that would be, so it was 180 miles. It's the same trip, but this one took 1.2 hours. And that is, so 150 miles per hour on the way home. And this gives me my system. Elimination is going to eliminate those y's right off the bat. So I've got negative 1w plus the 1w. Those are going to zero out. And I've got two airplane speeds, right, so we're adding these together, would equal 240 miles per hour. And we'll divide these by 2 to get the speed of the airplane, which was 120 miles per hour. All right, well, if this airplane was going 120, then we can replace it into one of the two equations. I'm going to use plus w, which was equal to 150, and just solve this, right? So I'm going to subtract 120 from both sides. And I see the speed of the wind, which is 30 miles per hour. And we see this works, right? 120 plus the 30 gives us the 150 miles per hour. And then the 120 minus the 30 gives us 90 miles per hour. Some of you guys noticed that the average of these two numbers, 90 and 150, is 120 as well. Or it's the number right in the middle of the two, okay? And that's the nice thing about these problems. If you don't want to do all that work, just find the average of those two, the two speeds, which tells you the speed of the airplane. The difference between those, the 120 and the 90 and 150, is going to be the same because of the average. So how far away is 120 from 90? 30. Well, how far away is it from 150? 30. So clearly the speed of the wind was 30 miles per hour. The admission fee at an amusement park is $1.50 for children and $4 for adults. On a certain day, 301 people entered the park, and the admission fees collected total $814. How many children and how many adults were admitted? Okay. So we should be able to get two equations once again. And since we're dealing with values, we'll need to define these. I'm going to say X is the number of children. That's not hashtag, you guys. Is that a generational thing? That meant numbers to us, okay? And then Y is the number of adults. All right, now we got our equations. First off, we see that 301 people entered the park. So if you took children and adults and added them together, you'd get 301 people. And then if we look at the costs, right? So it was, for children, it was $1.50 for every child. So if I multiply that by X, it will tell us how much money was brought in from the admitted children. And then it's $4 for every adult. So if we multiply that by the number of adults, we have as much as we would have collected for adult tickets. And that was equal to $804. So on the last part, the last problem like this, we used substitution. So I'm going to use elimination this time. And I'm going to choose to eliminate the y's. So I'm going to multiply this top equation by -4. Well, now the y's will eliminate. And if I add these two together, I've got negative 2.5 x equals negative 390. I just used the calculator there. And we'll solve this by dividing both sides by negative 2.5. So it looks like x is 156. So that's 156 children. And if we go back, children and adults was 301. So if I take children, 156, plus the adults should equal 301. And we'll subtract 156 from both sides. So y is 145, 145 adults. You need a 20% alcohol solution. On hand you have a 70 milliliters of 15% alcohol mixture. You also have 30% alcohol mixture. How much of the 30% mixture will you need to add to obtain the desired solution? Okay, so we've got three different concentrations, that's the word, of alcohol right here. And what we want is 20% solution, okay? Now, there's two unknowns on this. We don't know how much 20% alcohol solution we will have. And we also don't know how much 30% alcohol mixture that we have. Okay, we're just going to assume that we have enough of both. But we've got to make the 30% out of our 70%, 15%. I'm sorry, 70 milliliters of the 15% mix. So I need two equations because it's a system, right? And what I want is first the amounts of stuff. Let me take that back. The first thing I should do is identify my two unknowns, okay? X and Y. Yes, we're only solving for one of these, right? The 30% mixture. But the two things I don't know is how much of the 30% mix that I have. And I also don't know how much of the 20% mix I will have. So my first equation will be based off of volume, or the milliliters. So I will have my 30% mixture plus the 15% mix, which I know how much I have, 70 milliliters. And that would give me the 20%, how much of the 20% I will have. All right, the next one will be based off of concentration, which is a long word, so I'm not going to write it all out, okay? But I've got my 30% concentration, and I've got my 15% concentration, which, well, we know how much of it we have, right? 70 milliliters. And we're going to multiply it by the concentration as a decimal. That's 15%. Now when we add these two together, the x, which is 30%, right, that means I'm going to multiply it by 0.3. If you want to put a 0 at the end of that, that's fine. And then this should equal my 20% solution times how much of it that I have. All right, this is set up for substitution. So I'm going to replace the y with x plus 70. I'm sorry, I could multiply these two together, right? All right. Well, let's distribute this 0.2 in then. Now this sets up pretty nice for us, even just as it is. But remember, the question is how much of the 30% mixture we want or will need. And X is the 30% mix. So this is set up nice just to solve the problem and be done. I'm going to put my X's on the left. So I'm going to subtract 10.5 from both sides, and also subtract 0.2x from both sides. And then finally, just to finish the problem off, we'll divide both sides by 0.1. So x is 35. That's, you'll need to know how much. So that's in milliliters right there. 35 milliliters of the 30% solution.